Okay, we're on to 10.3, the quadratic formula. Ooh, which way am I going? This way? So what we've been doing in this unit is solving quadratic equations. What does it mean to solve an equation, a quadratic equation? By the way, what makes an equation quadratic, of course, is that exponent of 2. Hopefully you remember that. Well, graphically, solving it means you're finding where the graph crosses the x-axis. So this particular equation would have two solutions. They would be a -1 and 0.5. When we talk about the solutions, we talk about them as x equals a number. And we don't need the y value because the y value is always going to be 0 because any point on the x-axis will have a y value of 0. Other parts of the graph that we've talked about, the vertex. The vertex is either the minimum or the maximum. In this case, it's the maximum. And it's also the only point that's on the line of symmetry. So that's kind of sideways. That should maybe be over a little bit, like that. Those are important parts to the graph that you need to know. So some of you guys were doing 10.1 and didn't know what the vertex was. These vocabulary terms are important. You need to know what they are. What does it mean to solve an equation algebraically? It means you're finding the values of x that make the equation true. So we would have to solve it and figure out what x is. And when we're saying it makes it true, it means when we plug that number back in, so I'm plugging -1 into my original equation, I get a true statement after I simplify it all. Same thing here, I plug 0.5 in, I get a true statement after I simplify everything. So how have we learned to solve these? Well, obviously we learned how to solve them by graphing. We've also done factoring. You could always guess and check. And then the next way we're going to learn today is by the quadratic formula. So any quadratic equation can be solved by plugging into the quadratic formula. However, when you do it, you have to have it in this form. So ax squared plus bx plus c equals 0. So that's your standard quadratic form. That's what you want it to be in. Here's your quadratic formula. Bum, bum, bum. There it is. Yay! Yes, it looks like a lot. It is kind of crazy looking, but all you're going to do is plug into it. So it's just a formula that you have to memorize and then plug your numbers into it. So let me repeat that. You have to memorize this. All right, let's try one. Get right into it here. I am recording, right? Yes, good. That'd be awful. Okay, so the first thing you want to do is you want to make sure you're in standard form. So ax squared plus bx plus c equals 0. Sure enough, we are ready to go. The next thing you want to think about is what are your a, your b, and your c? A in this case, remember it's the coefficient that's in front of, let me write that down real quick, ax squared plus bx plus c. So a is the number in front of the x squared. A lot of times students want to tell me it's the x squared. No, it's never the x's. It's the number in front of the x squared, which in this case is 1. B is the number in front of the x, and you want to use your sign, so that's a -7. And c is the constant at the end, that's a +8. Okay? So then it's just a matter of taking those three variables and plugging into this formula. Some students want to put every single thing in here. Some students want to try to do it all at once. Some students chunk it up. You're going to find your own rhythm. However, you have to be careful how you do it, because if you try to do too much at once, you will run into trouble. And you cannot put everything in there at once. See this sign right here? That's called a plus or minus sign. And that actually means you have two solutions here. One with a plus sign, one with a minus sign. We don't stick that in the calculator. At some point when we're solving, you'll see we'll have to split it into two problems. So at no point should you just be sticking this whole thing in your calculator. It's a bad idea. Don't do it. Let me show you the way I chunk it up. The first chunk or piece I do is just -b. So I know b is -7, So negative b would be a positive 7 because negative 7 makes positive 7. Plus or minus the square root of, and then the next chunk I do is all of this. Okay. Okay, and I'm bringing up my calculator here to help me calculate this b squared minus 4ac. So on my calculator screen, I'm going to calculate b squared minus 4ac. Now I'm going to show you the wrong way first. B is negative, can't really see everything at once. Okay, there we go. All right, so b is negative 7. So negative 7 squared. This is the wrong way. Minus 4 times a is 1 times c is 8. And let me tell you, that's the wrong answer. Why? What did I do wrong? I want to square b. B is negative 7. Am I squaring negative 7 here? No, I'm only squaring the 7. So in order to square the negative as well, I have to use parentheses. So it has to be put in that format. Times 1 times 8. That is the right answer. Okay, so keep in mind that negative 7 put in this way is going to give you a different answer from negative 7 put in this way. The correct answer here is this one, okay, because we want to square the negative and the 7, which is going to turn it positive. So huge, huge, huge mistake students make. Make sure when you are squaring your b term, it should always come out positive, because whether b is positive or negative, when you square it, it's going to turn positive. When you're putting it in your calculator, you absolutely have to use these parentheses. Okay? In fact, let's make a note on your paper. When you square b, put b, whatever your b number is, in parentheses. Don't forget it. Don't make that mistake. You'll miss the whole problem then. Okay, so that was the next chunk I did, b squared minus 4ac, the correct one, 17. So I'm putting that in under my radical. The last chunk that I do is the bottom, which is just 2 times a, and 2 times 1 would give me 2. So I first did these 3 chunks. The next thing I'm going to do is calculate the square root of 17. So square root of 17, and we're going to round to the nearest hundredth unless it tells you something differently. So that would be 4.12. So I didn't do anything with the 7. I didn't do anything with the plus or minus. I'm just calculating this piece now, and that was 4.12. All divided by 2. Okay? At this point, you are ready to split it up. Remember I said this is really 2 answers? You have to do 1 with the plus sign, and you have to do 1 with the minus sign. So sometimes students will say, well, if we're going to split it up, why didn't we just start with 2 different things? Because this is a lot to write. It's a lot easier to write it all as 1. Keep it all as 1 until you have to split it. And this is the point where we have to split it. At this point, you can calculate each problem, but again, you have to be careful how you put it into your calculator. If I type in 7 plus 4.12 divided by 2, what's the calculator going to do first? It's going to do order of operations, and it's going to do the division first. But I don't want it to do that. I want it to do the addition first. So how can I fix that? I can use parentheses around the top. That would give me the right answer. Or I can actually use the fraction button and put the numerator in that way. If you're working at home or on a regular calculator, you're going to have to use parentheses because, again, and I'll show you what it looks like. If I just straight do it without parentheses or without the typing it in the numerator denominator, it's going to do this part only, and that is not what we want. So no, no, no. So that gives us an answer, the correct answer of 5.56. Okay, and now we're going to do the same thing on the other one. So I have 7 minus 4.12, and then divided by, oops, I'm not typing. Erg. Minus 4.12, and then divided by 2. And that one gives me an answer of 1.44. And technically I should be using the squiggly equal signs because these are not precise answers, they are approximate. In the next chapter, we'll learn how to get precise, exact answers, but for now, these approximate ones are just fine. Okay? So long explanation, hopefully you caught everything. What do these solutions represent? Well, that means if we were to graph this equation, we would get roots or zeros approximately right there. And I know because A is positive, it would open up. So I know my parabola looks something like that. I don't know exactly where my vertex is, but somewhere around there. I at least know my roots. Okay? All right, let's try another one. Excuse me. All right, so remember, the first thing you want to do, get it into standard form. So you have to subtract 1. We need it to be ax squared plus bx plus c. And now we're ready to go. So what is a? 2. B is 5. And c is -1. So once it's in standard form, it's just right in order. A, B, C. Always make sure you include the signs. Okay, so the 3 chunks I do, 1, the stuff under the radical, 2, and then 3. Negative b is -5. And then I pull up my calculator, and I do b squared minus 4ac. So parentheses 5 squared. Now in this case, when b is positive, you technically don't need the parentheses, but I would suggest you use them anyway so that you're in the habit of doing them when it is negative. Minus 4 times a, which is 2, times c, which is -1. And that gives us 33. Okay, and then my last piece is 2a. 2 times 2 is 4. All right, let's calculate the square root of 33. And we get 5.74. Okay, so 3 chunks, then the radical, or the square root, then split it up into 2. You'll do 1 with the plus of the plus or minus, and 1 with the minus. Okay, and then you're going to calculate it. Again, make sure how you calculate it is the correct way. Let me move so I can see it. -5 plus 5.74 divided by 4. First answer, 0.185, which would round to 0.19 because we are rounding to the nearest hundredth. Squiggly equal signs because we are not exact, because we have rounded. Okay, and then one more. Oh, and here's a little trick for you. If you guys go up to where you were just there, if you press enter on that, it'll bring it straight down, and then all you have to do is just change that plus to a minus. So just a little shortcut if you're interested. And that is -2.69 after you round. Okay? Now, you can check these, but they're not going to be 100% exact because we've rounded. So let's try checking one. So I'm going to plug 0.19 in to my equation. So I would have 2 times 0.19 squared plus 5 times 0.19. And I should be exactly 1, but I'm not going to be exact because I've rounded. Oops, I typed in 19. So here's that shortcut again. I just made one little mistake. Go up, hit enter, and then I can go in and hit that decimal. So you can see I'm very close to 1, but I'm not exactly 1, and that is, again, just because we rounded. So still you can check these. It's just not going to be a 100% check. But it's, I mean, if you got like 40 or like I got 95, that's definitely not right because I knew I needed it to be equal to 1. Now, had I checked this one, I would have wanted to be equal to 0. So just be careful. Make sure your left side and your right side are approximately equal. All right, pause the video. You guys try these two. All right, check out the first one. It was already, well, it was not already in standard form. We had to subtract 12x, and that should go in between the 9x squared and the 4 in order to be in standard form. It is extremely important you put it in standard form, or else you're going to have the wrong things for A or B or C. Okay, so that order is very important, and it's important that you don't just put them in order, you actually move terms. And by that I mean this is not a positive 12x anymore, it is a negative 12x. So here's my A, B, and C. I plugged in. My chunk that's under the radical ended up being 0. The square root of 0 is just 0. So 12 plus or minus 0 over 18. Now I did split them, but what happened? I got the same answer on either one because 12 plus 0 is the same answer as 12 minus 0. So if you get a 0 under here, then really you're only ever going to have one answer. Okay? So you don't have to go ahead and do all of this. You could just go straight into, I would say you could go from here to your answer, 12 over 18, and then reduce that to 2 over 3. Okay, so I don't need to see it split into 2 because it's going to be the same thing. The second one, here's my A, B, and C. It was already in standard form. Make sure you don't pull the x's as your A, B, and C. It's just the coefficients, which are 1, 1, and then your constant of 3. Now, when I did this one, I got this stuff for my 3 chunks. When I went to do my square root of negative 11, I ran into a problem. Non-real calculation. What's the problem with that? You're not allowed to take the square root of a negative number, right? Well, if I can't do this part of the problem, then I can't do the rest of the problem at all, which tells us what? No solution. Okay, so if we were to graph this, it's going to be somewhere up here, and it's never going to cross that x-axis. Okay, whereas this one would only cross it once, which means that's the vertex. It would touch it just one time. Okay, and those are all possible. You could get no solution, one solution, or 2 solutions like we got there. Okay, which brings me to the determinant. A determinant is the expression that's under the square root sign in the quadratic formula. So the stuff under the square root, that's our second chunk, and that's b squared minus 4ac. That part right there, just that part, just the b squared minus 4ac, will tell us how many solutions the equation has. Okay, so let's look back here. These ones with 2 solutions, notice your b squared minus 4ac, your determinant, was a positive number. It was 17. Here, where there were 2 solutions, it was a positive number. It was 33. So if the determinant is positive, there will be 2 roots. And what does that look like? That looks something like this. Or maybe this. But it's going to hit 2 different times. Okay? If the determinant is 0, like it was in this example, how many solutions did you get? Don't say 2, it looks like 2, but those 2 answers are the same, so it's only 1. So if your determinant is exactly 0, there is 1 root, and that 1 root is actually the vertex point. Okay, so something like that. Or maybe if it's opening down, it could be like this. Okay, And then the last option, if your determinant is negative, like this one was, we won't get any solution because we can't take the square root of a negative. Okay, so then that would be something either up here or something way down here, never going to touch your x-axis. So some problems will simply ask you, how many solutions does the equation have? Now, one way to do it would be to solve the whole problem and figure it out, but the other way is to just find the determinant. So if I'm only doing b squared minus 4ac, I still need to make sure I'm in standard form. I still need to know what a, b, and c are, but then I only have to calculate this part. So b squared, and I honestly don't mind if you don't show any work, if you just go right to your calculator. Well, that's not true. I want you to write down what a, b, and c are. But as far as the rest of it, you don't have to show the work. I'm okay with that. So b squared, you have to use the parentheses, don't forget. Negative 6 squared minus 4 times a, which is 9, times c, which is 6, gives me a negative number. So I know, because this is a negative number, and it doesn't even matter what the number is, but as long as it's negative, there will be no solutions. If it were positive, there'd be 2 solutions, and if it were 0, there would be 1. Okay, that's the quadratic formula and the quadratic formula's determinant and what you use it for. Go ahead and keep working on your pocket.